Hi everyone, today we are going to start 2.4, which is use of postulates and diagrams. Postulate or axioms, rules that are accepted without proof or a statement assumed to be true. Theorems, rules that are proved. So we're going to start with our point, line, plane postulates. I would get out a piece of paper right now, make sure you write all of these down. You are expected to know them. So the first postulate is through any 2 points, there is exactly one line. The next postulate, a line contains at least 2 points. And finally, if 2 lines intersect, then their intersection is exactly 1 point. And we learned these terms in chapter 1. Next slide. Through any 3 non-collinear points, there exists exactly 1 plane. So I have a little diagram here. So if we have 3 points, there exists exactly 1 plane. A plane contains at least 3 non-collinear points. So as you see, this postulate is opposite of postulate 8. So if we have a plane, we know that there must be at least 3 non-collinear points. 10. If 2 points lie in a plane, then the line containing them also lies in the plane. And finally, if 2 planes intersect, then their intersection is a line. So once again, I would make sure all of those are written down because you are expected to know them. All right, so here's our first example. I want to state what postulate is illustrated by the diagram. So let's look at A. So if, and it looks like we have 2 lines, then, and we have a dot in between the 2 lines. Looking back at your postulates, which postulate is illustrated here? Well, the correct answer is postulate 7, and you don't need to know what it's called. You don't need to know that, oh, this is postulate 7, but you should be able to tell me that postulates, or that this is if 2 lines intersect, then their intersection is a point. You should be familiar with that. Sorry about my handwriting. Scroll down. Part B, which postulate is this representing? The correct answer is postulate 11, which states if 2 planes intersect, then their intersection is a line. Interpret a diagram in 3 dimensions. Which of the following statements can be assumed from the diagram? There are certain things that can be assumed and cannot be assumed. Assume just means by looking at the diagram, we can say that this is true. If it's not in the diagram, we cannot assume that it's true. So for example, A, B, and F are collinear. So if I look at points A, and I'll circle it, A, B, and F. Are those points collinear? They are. So this can be assumed. Now let's look at points E, B, and D and see if they are collinear. So we have E is here, B is here, and D. Can we assume that those are collinear? The answer is no. We don't see a line that connects all three of those points. So I'm going to circle this one here because the question did ask which ones can we not assume. That is one of them. Next, we see segment AB is perpendicular to plane S. So let's find line AB is right here. So I'm just highlighting it. Plane S is this orange reddish looking plane. And if you notice, we see this red box. That red box means that that angle is equal to 90 degrees. So are these perpendicular to each other? The answer is yes. So we can assume this. Next is segment CD perpendicular to plane T. So I see line CD here, and I'll highlight it. And plane T is the blue plane. And I do not see a red box anywhere. So can I assume that those are perpendicular? The answer is no. So I am going to circle that there. And for the final one, line AF intersects line BC at point B. Let's check this out. So AF is this line right here. BC is this line right here. Do they collide at point B? And the correct answer is yes, it does. So we can assume it from the diagram. Perpendicular figures. A line is a perpendicular figure to a plane if and only if the line intersects the plane at a point that is perpendicular to every line in the plane that intersects it at that point. So here's a little bit of a diagram. So all it's saying is line T is perpendicular to plane A, which is the blue plane. And if we draw other lines from that point of intersection, we'd also see that those are 90-degree angles. Sketch a diagram to show line TV intersecting segment PQ at point W so that segment TW is perpendicular to segment WB. All right, so the first thing I want to do is draw line TV, and I want to label the parts. So I'll draw a line here. Remember, lines have arrowheads. That's important here. So I'll name this point T and this point V. Next, I'm going to draw line or segment PQ. There will not be any arrowheads there because this is a segment, so it does stop. So I'll call this guy P, this guy Q. It also says that the line and the segment intersect at point W. So I then can name this guy W. And the last thing that it does tell us is that W is in the middle, so it's the midpoint. So TW is congruent to WB. So I can put tick marks there. So that's telling myself that those segments are congruent. And I'm done. Let's try this again. Sketch a diagram showing ray FH is perpendicular to segment EG at its midpoint M. All right, so the first step here is I'm going to draw ray FH. So F has to be my endpoint of the ray. H is going to be the arrowhead. So F and H. I'm going to draw a segment. I will name this E and this one G. The midpoint is M, so the intersection, once again, is going to be M. So I know then that FM is going to be congruent to MH. That's the definition of a midpoint. It's in the middle. And then don't forget that it also told us that those two, the ray and the segment, were perpendicular. So I want to draw that right, or that box representing that that is equal to a 90-degree angle. All right, last problem here. Which of the following cannot be assumed from the diagram? So this is very similar to our previous problem. So can we say that A, B, and C are collinear? The correct answer is yes. If we look at the diagram, and I'll highlight this, those points are on the same line, which means they're collinear. Line EF is perpendicular to line L. Can we assume this? Well, let's look at our picture. So EF is this line here. Line L is this line here. If you look closely, you see that box. So are they perpendicular? Yes, they are. So we can assume this. Next is line BC perpendicular to plane R. So line BC is this guy here. Plane R is, I'll try to highlight it, is this plane here. Oops. All right, so if we look closely with this line and this plane, we do not see a marking. The other mark was telling us that line L was perpendicular to plane S, but we don't see any markings on this line to tell us that we have a perpendicular or a 90-degree angle. So this is something that we cannot assume. Even though it may look like it, we cannot assume because we do not see that marking. Line EF intersects line AC at point B, and we see that in the picture. So this is actually true. We can't assume it. So here is EF, here is AB. It collides at point B. Is line L perpendicular to line AB? So I have line L here, line AB. Are those two perpendicular? This is no, we cannot assume that, so I'm going to circle this. And if you look at our lines, we don't see a marking like this. That other marking is marking something else, but I do not see a marking of just those two lines, so we cannot assume this. It's not true. And finally, our points B, C, and X collinear. That is also no. We cannot assume that. We do not see a line connecting all three, B, C, and X. It's connecting B, C, but X, there's not a line. Even though it looks like if we were to extend that line, it could hit X. We don't know that for sure because there's not a line there. So that is something we cannot assume.